Let's look at this geometry problem, and we have two squares A, B, C, D, and D, E, G, F, right? Two squares. They are kind of positioned in this kind of awkward way, right? And it's asking us to actually prove that if we connect AE and connect CG, the area of the triangle ADE, that's S1, should equal to the area of the triangle CDG, that's S2, right? So how do we solve this problem? How do we prove that S1 equals to S2, right? So let's look at both S1 and S2 then. They are triangles, right? They are triangles, right? But the side length DE of this triangle ADE is actually the same as the side length DG of the triangle CDG, right? Because it's a square, right? So these two side lengths is the same. The same is true for these two side lengths, AD and CD, right? AD and CD. So, so to prove that the area are the same, what we could do is to actually prove that the height. So suppose we treat DE at the base of ADE, this triangle, right? And then it's gonna have a height, right? And then CDG, if we treat DG as the base, and then it's gonna have also a height, right? So if we can prove that the two heights are the same, then we can prove that the area is the same, right? Because the base is already the same. So how do we actually get the height? So let's look at the triangle ADE. What's going to be the height, right? So let's try to extend DE. Let's try to extend DE. Just to make a straight line. Just to extend DE, make a straight line. Right? Let's try to make it as straight as possible, right? So let's extend DE. And then the height is going to be like that. Right, that's going to be 90 degrees, right? Yep, that's going to be 90 degrees, right? So this is an extension of DE, right? That's going to be the height, right? But let's draw another vertical line from C to this extension of DE, right? Let's draw another vertical line over here from C to the extension of DE. So this is going to be 90 degrees, right? So why do I want to do that, right? Because if you treat for the triangle CDG, if I treat DG at the base, then the height is going to be over here, right? That's going to be 90 degrees, right? So if I draw a vertical line down, then I'll get a rectangle over here, right? This is 90 degrees because this line is an extension of DE, right? So then I can move the height of this triangle over here, right? Because it's a rectangle, so 90 degrees, right? That's a 90 degree, that's a 90 degree, that's a 90 degree, right? So the height of this triangle CDG with DG at the base is going to be moved over here, right? And then the height of ADE, and the height of the triangle ADE is going to be over here. So if I want to prove that the height of the two triangles are the same, all I have to do is to prove that this line, which is the height of ADE, should be the same as this line, right? Which is the height of the triangle CDG with the DG as the base. That's this line, right? This line is the same as this line. So all I have to do is to prove these two lines are the same, right? Can I prove these two lines are the same? Can I do that? So if we look at this triangle, so let's call it H, right? This point as H and this point as I, right? This point as I. So we're going to look at the triangle AHD. That's this triangle over here, and the triangle DIC. That's this triangle over here, right? So let's look at these two triangles. They are both right angle triangles, right? So this is 90 degrees, this is 90 degrees, right? And they share the same side. So AD is the same as CD, right? Because ABCD is a square, so AD is the same as CD, right? So now we have two conditions that are identical for these two triangles, right? So the next thing that we're gonna look at is this angle, right? This angle and this angle, are they the same? Yeah, I think so, right? Why? Suppose this is angle 1, right? So 1 plus this angle 2. So angle 1 plus angle 2 should equal to what? Should equal to 90 degrees, right? This angle plus this angle should equal to 90 because this is a right angle triangle, right? And then this angle, suppose this is 3, right? So angle 3 plus angle 2. Angle 3 plus angle 2 should also equal to 90 degrees, right? Right. Why is that? Because this is a square. ADC is a AD. So ADC angle 2 plus angle 3 is going to be 90 degrees, right? So this is a square, right? The angle ADC is a right angle, right? So if we subtract these two equations, we get angle 1 equals to angle 3, right? So angle 1 equals to angle 3. So for these two triangles, DCI and ADH, we have three conditions that are identical. So these two triangles are identical to each other, which means this side AH is indeed the same as DI, right? So AH equals to DI, right? H equals to DI, right? And so the area S1 is going to equal to what? It's going to equal to DE. Suppose the side length is A times AH. Suppose the height is B, right? So A times B divided by 2, right? S2 is going to equal to what? S2 is going to equal to, so this is B, and then so DI is going to be B2, right? So this is going to be B, right? So this is going to be B2, right? Because this whole thing is a rectangle, and then DG is A, right? DG is A divided by 2. So S1 equals to S2, right?